So the Student Cluster Competition is a high-performance computing challenge where students from all around the country build and design their own high-performance clusters. On these clusters, they'll then install their own operating systems, their software, their device drivers, and run a series of applications and benchmarks that are used in industry. So some of these applications include the very same ones that are used to categorize and place the top 500 computers in the world.
High-performance computing is basically computing power where it is able to perform complex calculations and process data at very high speeds. So you can think of it as multiple or thousands or close to millions of processors trying to achieve those tasks.
The advice that I can give the student who's going to participate for the next coming years for a CHPC competition is that the student must be well able to work as a team and then must be open to learn more and do the preparation enough and do the research and networking, because CHPC is a bit challenging, but also it is a great experience for the student.
I'd say that the kind of main piece of advice that I could give to students is to just do preparation, because you are given the task you'll need to perform beforehand, like a couple months in advance. So if you use that to your advantage and kind of start preparing that very straight after the tutorial round pretty much, then by the time you get here, you'll be pretty comfortable with the benchmarks and setting everything up and running things. So it'll pretty much be a piece of cake just to get it to work on the day. There's always issues and you'll never be able to solve all of them. But if you have preparation, it really gives you a leg up in actually solving the problems as they come up.
All I can say is teamwork makes the dream work. So work well with your team and grasp as much information as you can from the first round.
All right, talking about democracy in IT is a very vivid term right now. And I say this in light of what the pandemic has taught us. The pandemic has shown that there is a huge need on dependable cyber infrastructure. And in that case, I'm talking reliable and highly available. The SEC is challenging us to be able to build these types of clusters so that businesses that are moving remote can have these systems at a more cost-effective price point.
So given the type of problems that we have in the continent, especially in South Africa, we're having this energy problem and also having sustainable energy problem. So having access to this type of clusters, it can be able to help the youth step up into the plate of trying to solve the challenges that we have in South Africa. So ahead of the COP27, we had a discussion around the energy crisis at the University of the Witwatersrand. But these discussions alone are not enough. We need resources to be able to solve this type of problems. So that's why we have this type of clusters. So right now I'm currently running a benchmark called RAF. This is the type of benchmark that I can use to model where I can place solar panels so that I can receive the highest concentration of the sun. So me being able to use this type of model and benchmark to try to solve the problem that we're currently having in South Africa, nothing can beat that.
We have focused on doing more research based on the findings, based on the student cluster competition we went through on the first round, and gathering more reliable resources, and also asking assistance from our previous students in our academy.
So after the tutorial round, we prepared for the competition by trying to configure our own cluster using the servers that are available at VERDS. We managed to get through the networking, and so that it was easier so that when we get here, so that's what we did.
So what we are currently stuck on is we are trying to get one of our nodes to connect to the head node and the other node to connect to the internet through the head node. So we are kind of trying to configure that. So yeah, that's what we are currently working on right now.
We've learned a lot actually from this HPC clustering, because we've always seen servers as machines that we just use for running application banks and stuff like that, but learning how that we can cluster them and run them remotely, stuff like that, it's really interesting.
I think that the CHPC gives us such a good opportunity to actually experience stuff that we wouldn't have a chance to before, because we get to play with clusters and material and hardware that we wouldn't ever get a chance to otherwise. That's why I think it's such a good opportunity for our country that we do have competitions like this, so that we can progress.
So we have studied a lot of things. We have studied coding. So when we got here, we were doing networking. So in networking, we have learned a lot. We have learned about pinging. We have learned about connecting clusters to our head node. So we have 3 servers that we're working on. We have the head node, we have the 2 compute nodes. So Yeah, and our motto is that in teamwork, one is a drop and two or more is an ocean.
I've learned quite much in terms of like the Linux environment, more than what we taught at university. So it taught me about Linux in depth and the type of things it is used for even outside in most companies and stuff, and just more information about supercomputers and other stuff. And that has made me, open my mind into a lot of careers I can go to and the stuff that I can actually pursue.
If we win, it's going to be a good thing because we will be able to travel abroad, be able to meet with new people, compete with people internationally, and then we'll have to learn from experts, and that's a good thing.